Okay guys, so welcome back again to our new video. So in this video we are going to do some small problems regarding the SN1 mechanism, SN2, E1, E2. We are going to see how we can approach this problem and determine how we can take the answers for it. So if you remember in our previous video we have constructed this chart. We have talked about all the mechanisms, like how each of these factors affect our reaction mechanism. Okay, so I hope you are okay with this. If you are not, I highly recommend you to go back to our specific video and watch it. I will put the link in here so you can easily go and watch it. So it's a lengthy video, but I have explained every small details in the mechanisms and all the aspects. So let's move on to our problems. So first problem here, you have to determine what is the mechanism and you need to draw the products. So let me take the blue color. Okay, first of all you have a tertiary alkyl halide, right? This is a tertiary alkyl halide. In this case this is your nucleophile, and here you have the solvent. Sometimes in your exam paper you may not have both of these two, like nucleophile and solvent. Both of these two reagents won't be displayed on your questions. Sometimes the question would be like this: your only reagent is this. So don't be afraid or don't be confused. This is basically the same thing, right? So if you have a reagent like this is the solvent. So the nucleophile which is forming from this solvent is the anion form. You just need to remove the H. Here you have the nucleophile, right? So that's a small point. Let's move on. So now we need to go to each of those points, each of those factors, right, and see in what mechanism the reaction favors, right? So in this case I have told you best way to deviate, best way to divide from substitution reaction and elimination reaction is to look at the nucleophile, right? From nucleophile you can easily get mostly you can get the idea whether it's a substitution and electrophilic, and you can approve it by looking at the temperature. So in this case let's first look at the nucleophile. Okay, so first let's look at the nucleophile. Here you have the nucleophile. This is a bulky nucleophile, right? This is the structure. It's like this now. You can see it's like this. This is our nucleophile. So this is a bulky group, right? This is a bulky group, which means this is not a good nucleophile, but this is a strong base. I have talked about the relationship between the base and nucleophiles. These are important points, guys. Okay, so these small points you need to know these things. So like I have talked all about in our previous video, so I can't give another time to explain it again. So if you want to look at it again, go back to that video and watch it before you come into this one. So this is a strong base, which means our reaction favors elimination, right? Our reaction favors elimination. You can't directly say it's a elimination reaction, no, but it favors one, right? And now if I go to look at the temperature, you can see temperature is also very high values. So again I can increase my tendency towards the elimination. A very important point: never look at the temperature and make a decision. No, right? Never look at the temperature and make a decision. So in this case, right, this temperature and solvent, these two factors, don't take decision based on these two factors. You use these two factors to verify your decisions, right? You need to take the decision based on the substrate and nucleophile. Sometimes a leaving group is also okay, right? So after you have taken a decision, you can verify it using these two things. Do not look at the solvent and temperature at the first. So in here I have looked at the nucleophile. Now I can say it's a electrophilic, it's a elimination. I will verify it using the temperature. Now let's look at the substrate. You can see substrate is a tertiary one, right? This is a tertiary one. So with the tertiary ones, so we are on elimination path now. So tertiary ones, both are okay with the tertiary ones, right? E1 mechanism, E2 mechanism, both are okay with the tertiary ones. So now how we can configure whether it's a E1 or E2? Now we can go to the last factor, which is the solvent. So this is basically a protic solvent, right? So you can look at the solvent, and polar protic solvents are favored by E1 mechanism. So this should be E1 mechanism, which means first this Br group will be removed, and then this will come and attack to our original molecule. So I hope you are okay up to now. Now when I am writing the products, let me write the products. So there can be two products, right? You know these things. Isomers, I guess you know, right? You can use your nucleophile or your base to attack this particular hydrogen or this one of these hydrogen. So based on the attacking hydrogen, two products will be formed. So here's the first product. And the other product is this one. So if your mechanisms give you two products, right, you need to mention what's the major product and what is the minor product. So in this case, you know, most stable one is this one, right? It's based on the elimination mechanism. I hope you know, right? When this eliminate, this has a positive charge. Sorry, this has a positive charge. I hope you know the mechanism. So this is the most stable compound. So this is the major component, major product, and this is the minor. Now let's move on to the second one. Okay, now in this case you can see we have this substrate and we have another nucleophile here. You have your what you call solvent here, right? So first look at our nucleophile. Right? The order is okay, right? You can first look at the substrate also. It's completely fine. But for me, I will go for the nucleophile. So you can see this is not that much bulky group, right? This is not that much bulky group. So this is a strong nucleophile. It's a strong nucleophile. It's also a pretty much strong base, right? It's also pretty much strong base. But I would say this is a strong nucleophile because it's less bulkier. So I will go tendency towards my substitution reaction because of this less bulkiness. But that doesn't mean it's substitution reaction. No, it can be elimination. I have only looked at one component yet, but like from this observation, I will go towards the substitution reaction. So then I can see temperature is also lower, which verifies my substitution reaction mechanisms. Okay. Now I can see look at my substrate. You can see my substrate is a tertiary one. If you look at our chart, the tertiary ones supports SN1. Here you can see tertiary ones are supporting SN1 mechanism. So, and also you have a polar protic solvent here. You can see polar protic. It also verifies your decision. So in this case, I am going to select this as SN1 mechanism. Okay, so here you have the final product CH3 carbon and oxygen CH2 CH3. So this is our product. So it's going to be only one product. Okay, only one product. But if you remember, the conformation can be changed, right? Configuration, it can be changed. So I hope it's okay up to now. Now let's look at our third example. Here you have the nucleophile. This is the nucleophile, and here you have your solvent. Here you have your substrate. So when I look at my nucleophile, it's a very good nucleophile, right? And also it's a very good base. It's a good nucleophile and it's also a very good base. So this is less bulkier, so I will go towards my substitution parts. Okay, I will go towards my substitution part. This is less bulkier, and when I look at my substrate, you can see this is the point which I have to look upon, right? This is the point which I have to look upon. You can see this is a tertiary one. This is a tertiary one. This is a tertiary one. So temperature has not been shown yet, right? Temperature has not been given to us. So because of this less bulkiness, I will go towards my substitution reactions, and also this is a tertiary one, which means I would have to go towards SN1. And also this is giving me the polar protic solvents again, which verifies my decision as SN1. But in this case, so the product will be like this. Here, look at this. The product will be OCH3, CH3 and CH3. So in this case, you can see like you may have a problem like how we can exactly say this is a SN1, but it can be E1 too, right? It can be E1 too because it's a very good base. Here you have a very good base. So it can be E1 mechanism too. Yes, it can. So but most majority, like most percentage, favors the SN substitution reactance. So this is the major product. There can be minor products, okay? There can be minor products. So minor product can be like this. This is the minor product. Minor product is coming from E1 mechanism. So this is the minor. Right? So like when it comes to the exams, you can if you have a question like this, you can write the both and you can write a small explanation, right? Why you have drawn this structure as a minor. Like it's because like the temperature is not given. First this temperature is not given. So and also this is also a good base. But only problem is this is less bulky. If this is a bulk group, then you cannot go for substitution at all. You need to go for elimination. That's how we are going to do it. Okay, so let's move on to the final question here. Here in the there's a small point I need to I want to highlight to you. This OTS. Basically, these OTS groups are very good leaving groups, right? These are very good leaving groups. So basically, like you need to understand that. So if you see a very good leaving group, right? If you see a very good leaving group, it can drive towards the first order mechanisms. If you remember our mechanisms, so let me take to SN1 here. You can see SN1, it starts with the leaving of leaving group. So if this leaving group is a very strong leaving group, then it can drive this reaction forwards. So better leaving groups means it's SN1. Not SN1, it's a first order mechanism. It drives towards, right? You cannot take the decision the first time. I mean, you cannot take the decision suddenly, but you can think about it. So when I look at my nucleophile, you can see nucleophile is a very good nucleophile. This is a very strong nucleophile and also a good base. So and you have a substrate of secondary. Now look at this. I have at the leaving group also, right? So you know that the strong leaving group supports the first order ones. So here I have mentioned it also. So the thing is here, now we have a secondary structure, which means we have a substitution which supports both secondary structures. This cannot be a elimination, right? This cannot be elimination because of this less bulky group. So this is a less bulky group. This can easily go through our molecule. So I would say this state we can go for substitution. So let's move on with substitution. But we have a problem, right? We have a good leaving group. Yes, we have a good leaving group here. You can see we have a good leaving group, but we have a secondary structures. Now to help with that, and also we have very good leaving group. We have very good leaving groups here. We have a good leaving group. So in this case, we can take our solvent for our help. You can see our solvent is DMSO. DMSO is a polar aprotic solvent. Here it favors SN2. So in this case, I will go with SN2 mechanism. So major product, I will go with SN2 mechanism. But like these reactions, you can introduce a minor product as a SN2. But both are the same. So here the product will be like this. Substitution reaction. So this is SN2. I hope you get the idea about these small practices. Like you need to practice this, but you can find more question in internet also. So we are going to do more questions and problems maybe in next few days. So we will upload it as soon as possible. So all the best. I hope you got something from this video.